and you are taking 2 points, P and Q, like this, and we are trying to determine the result of their addition. Is the equation of the curve is y squared equals x cubed plus ax plus b. If we want b, we are not going to write that continuously. Then we are going to notice that p and q satisfies these equations, both of them, and the points are free for the third intersection of the line with the curve is on the equation of this line. The equation of that line will be something of the type y equals lambda x plus v. And for a line determined by 2 points, P and Q, we know that the slope can be computed as y q minus y p divided by x q minus xp. Right? So the slope determined by 2 points. And therefore, the v here can be computed from the value for that we have for one of the points, let's say p. We know that yp equals lambda times xp plus v. Therefore, v is going to be equal with yp minus lambda xp. Right. C is yp minus lambda xp. Just move it on the other side. And now I can combine these two equations to find out the third point. So I'm going to say that instead of y, I'll write its value here. So lambda x plus v squared is congruent in our case with x cubed plus ax plus b. Therefore, lambda squared x squared plus 2 lambda vx plus v squared is x cubed plus ax plus b. And I'm going to pass everything on the same side, so I'm going to get x cubed minus, because I'm taking x on the other side, minus x squared times lambda squared plus x times a, and here minus 2 lambda v, plus b minus v squared will be 0. And for this equation of degree 3, it can be solved, but we don't need to solve it with general formulas. Actually, we can use VID's rules, right? So you remember VID's rules? They are taught very, very early, 6th, 7th grade, so most people forgot them by now. And I'm not sure they are repeated at university. Did they repeat them in the linear algebra courses? But we can write them.
Who's the guy? Maybe we know the rope, we just don't know the guy.
He's famous. Negation of degree 3, if decomposed, can be written like that: x minus x1, right, times x minus x2 times x minus x3. That's how you write a monic polynomial of degree 3. It has the highest exponents at 1, and where x1, x2, x3 are the roots, right? Agree?
Yeah.
Therefore, you can decompose this, and this is equal to with what? With x cubed minus an x squared. So you have x squared, and if you have x squared times x3, x squared times x1, x squared times x2, and because x1, x2, x3 are always minus, you have here minus, and you have therefore x1 plus x2 plus x3. Then you have x's. Each x goes with two negative numbers multiplied, that becomes positive, therefore you are going to have the products, possible products of 2, x1, x2 plus x1, x3 plus x2, x3. And then you have the term, which is minus x1, x2, x3 equals 0, right? So VID's equation for degree 3 is telling you that the sum of the three roots of your monic polynomial of degree 3 is guaranteed to be equal with the minus of the coefficients of x squared. Otherwise saying x1 plus x2 plus x3 will be equal with lambda squared. In our case, you already know the x for 2 points on the graph, so we know xp and we know q, and the only one we don't know is the xr. But we know that their sum is x squared, therefore xr is equal to lambda squared minus xp minus xq. Okay? And now we can compute, because we know xr, we can compute directly yr. Why we can compute it? We can compute our yr because it's on the line, and we know the equation of the line now. And the equation of the line, we know its equation and we know the point. So we will not use the quadratic, the elliptic curve, because we don't want to solve the complex equation that comes with it. We already know the axis. We can just find the point on the axis. So yr, by the way, is symmetric of yr prime. So it's minus, and yr prime is the value of this function in the point xr. Therefore it's minus lambda xr and plus v, and we have v plus yp minus lambda xp. Otherwise saying yr is equal with, in our case, it's minus, I take this one, minus lambda, it's getting lambda xp minus xr, and you have a minus xp, yp. Okay, so these are the equations of the points that result from addition. There's one special case over there. Right? The special case is for this point over here. We know easily that sum of p times q, you don't need a special formula. You need just to detect that you are in the special case, and you know the result will be O. Okay? We know the special point of the point here, P. You know that it added with itself will also be O. What about adding 2 points, a point with itself that is here somewhere? Then you have to look at this tangent, and the result will be here. Okay? So if you just add P with itself to get the tangent over here, how will you address this? Well, you will need to, all the equations are the same, the only difference, we need the slope. And we cannot compute the slope with this equation over here. That's the only place where we use Q was for this equation, otherwise we only use P. We use Q to define the slope. This lambda. So now we need to find out the slope without Q. So to find the slope without Q, we are going to return to our formula, x cubed equals x squared